Hello students, this is Indrani ma'am from Rasayan. In this lecture of NEET Preparation Series from Hydrocarbon chapter, I am going to discuss some more questions from previous year NEET exam and other PMT exams. First question, which of the following will not show geometrical isomerism? 4 compounds are given. Each compound is having double bond. That means restricted rotation is there across the double bond. Compound which will have different groups on each carbon atom of the double bond will show geometrical isomerism. So here on this double bonded carbon, hydrogen and deuterium is there. Here fluorine and chlorine is there. So it will show geometrical isomerism. Here on each carbon different groups are there, so it will show geometrical isomerism. Here on each carbon different groups are there. Here methyl, here ethyl, here methyl, here ethyl. So it will show geometrical isomerism. But here on these double bonded carbon two same groups are there. Therefore it will not show geometrical isomerism. Therefore option D is your answer. Option D. Now next question is very interesting. Which of the following is the major product of dehydration of this alcohol? 4 products are given. So what we have to do? We have to do here dehydration reaction. Take the substrate. In presence of H plus, what will happen? Oxygen lone pair will be donated to H plus and we will get this oxonium ion. Now break this bond to neutralize this positive charge. So by removal of water we will get this carbocation. With this carbon, 2 more carbons are attached, so this is secondary carbocation. Now what we have to do? We have to shift this ethyl group from that adjacent carbon with its bonding electron from here to here. So what we will get? This carbocation. So you can see this carbocation is tertiary because this carbon is bonded to 3 more carbons. So this is more stable than this carbocation. Now what will happen? Removal of H plus takes place and we will get this alkene. Therefore option C is your answer. So what is happening here? Dehydration and rearrangement. Next question. Arrange the following alkyl halides in decreasing order of rate of beta elimination reaction with alcoholic KOH. So with alcoholic KOH mainly E2 elimination reaction takes place. Now see, with respect to this leaving group, this carbon is alpha, this carbon is beta. Here this carbon is beta. Here this carbon is beta. So what will happen? Dehydrohalogenation takes place. Br will go from here and hydrogen will go from beta carbon. Now see what is happening here. Here no branching is there at beta carbon. Here at beta carbon 1 methyl group is there. Here at beta carbon 2 methyl groups are there. Remember, with increasing branching at the beta carbon atom, whatever alkene we are getting after dehydrohalogenation is become more stable because it will become more substituted, and the reaction takes place with a transition state which is more stable, so reaction will become faster. So you can see this carbon is attached with 3 more carbons, so this is tertiary carbon from where beta hydrogen is eliminated. This carbon is attached with only 1 carbon. This is primary carbon from where hydrogen will be eliminated, and with this carbon 2 more carbons are there. Therefore this carbon is secondary carbon and these hydrogens are secondary hydrogen. So the hydrogen which will be removed is secondary hydrogen. And for E2 elimination reaction we know rate of reaction is like this, from where beta hydrogen will be eliminated. So from here beta hydrogen will be eliminated in much more faster rate because this is tertiary hydrogen, and next will be this secondary means C. After that B. So option D is your answer. You can see after dehydrohalogenation, whatever alkene here we are getting, it is disubstituted alkene, because two hydrogen atoms of alkene are replaced by methyl group. This is unsubstituted we are getting from here, and this alkene whatever we are getting from here is monosubstituted. So this is most stable, this is next stable, and this is least stable. Next question, which of the following reaction is incorrect match regarding the given product? Now see on the arrow it is given sodium borohydride, which is reducing agent. So these are alkyl chloride, means alkyl halide. With this carbon, since two carbon atoms are attached, so this is 2-degree alkyl chloride. With this carbon, since 3 carbon atoms are attached, so this is tertiary alkyl chloride. And since this carbon is attached with only one carbon, so this is 1-degree alkyl halide. Sodium borohydride reduces 2-degree and 3-degree alkyl halide to alkane. So this is correct reaction, this is also correct reaction. But here there is no reaction. You will not get this product with primary alkyl halide. So this reaction is not possible, because these reactions takes place via carbocation formation, and since 1-degree carbocation is not stable, so this reaction is not possible. Now it is given 1-degree, 2-degree, 3-degree alkyl halide. On the arrow it is given triphenyl tenhydride. It is triphenyl tenhydride. This is also reducing agent, and it reduces all types of alkyl halide to corresponding alkane. So this is also correct. So which option is your answer? This is incorrect match. Actually here there is no reaction. Hope it's clear to you in this video till this. If you like, please subscribe. Thank you for watching.